Hello, everybody, and welcome to the launch event of the Internet Computer Chain Fusion Hackathon. My name is Yasin. Very happy to have you all here. The wait's finally over, so we're going to be kicking off the hackathon today. Feel free to say hi in the chat section. Would love to know where you're all coming from. Always lovely to see active people in chat engaging, and we're in for some great. Hi, Thomas from Berlin. For those of you that are actually in Brussels for ECC, make sure to come by, say hi. There's a lot of people that I've already met and having a great time in some really nice and lovely summer weather. To kick things off, we are Encode Club. Those of you that have not done events with us, we are just a global community of top developers, professionals, and talented students in emerging tech. We organize a lot of events. We've done so previously, and we'll keep on going with a lot of interesting ones. This one is going to be led by myself. I'm Yasin, and I'm going to be the program manager for this hackathon. You can use the QR code on your screen if you want to get in touch, ask some questions, and generally, reach out in case there's issues you might need some help with. We at Encode Club do a lot of different type of events. We are doing a lot of Educate series. We do a lot of hackathons such as this one's, the best teams of which we move on to accelerators, where we try and produce actual startups and companies. We do a lot of boot camps for people that want to refine their skills, and then we help out with recruitment so that people end up, in the companies that we like to work with within the emerging tech sector. In the current case, we are happy to be kicking off an amazing hackathon with the Internet Computer, which is going to be a 4-week hackathon centered about leveraging the Internet Computer's new chain fusion technology to build multi-chain dApps, integrating ICP with Bitcoin, Ethereum, and other EVM chains. Our main sponsor for the event is going to be the Internet Computer, and we have an amazing team that will be supporting you for the duration of the hackathon, helping you with any questions that you might be asking, with a lot of technical support for the duration of the next 4 weeks. What is it to come? For those of you that are still have not registered, make sure to use the registration links on our website to indicate your interest and enroll in the program. Afterwards, please make sure to proceed to our Discord, where you can form a team. Make sure to introduce yourself, share the things that you are able to do, the things that you would be looking forward to, finding people that will be able to sync with you and help you on your developer journey. Attend the workshops. We have an amazing lineup of workshops, with one starting immediately after this launch session, and then proceed on to build your project and attend any one-to-one mentorship that might be happening either with our team or from the Internet Computer team. In the end of the program, we would love if you end up submitting your project. A lot of people, make it up until that very last step, but then not actually submit because they're thinking, well, maybe I did not actually achieve what I set off to. But my word of advice is, do your best and submit your best work, because it's a huge step in your developer journey to actually submit something for a hackathon. That is a win on its own. Moving on, we are going to be supporting you along your journeys. We want to make sure that all of you are getting a lot of support that comes in the form of workshops. We have interesting speakers that have lined up a lot of topics that for you that will be helping you to deliver something of value towards the end of this hackathon. There's going to be a lot of technical support. As I said, you can join on our Discord and make sure you post your questions, and we'll forward them to the right people so that you get the support that you need. Our Discord community is extremely active. You will see every Encode team member always pretty much online, ready to support you, ready to forward questions, ready to reply. So do reach out to us. We are happy to hop on calls. We're happy to do one-on-one support. Let us know what you're trying to build. What are the issues that you're having? What is it that we can help you out with our sole goal being to support you so that you end up submitting something by the end of these 4 weeks. Now, for those of you that have not yet seen our bounties and prizes, I would like to introduce Moritz from the Internet Computer team, who are at the stage to introduce the general bounties and share a couple of words for the hackathon itself. Moritz, you should be seeing a pop-up on your end in about a second.
GM, everyone.
Hello, hello.
Hi. Yeah, very happy to be here. I think this is actually the first or maybe even fourth time I'm participating in one of the Educate series or one of the Educate sessions, actually. I think in the past I led one or two of them. So I'm always very, very happy to be here. I always really like what Encode Club is creating, and I'm very happy to participate in today's introduction and then later on also giving one of the first workshops about chain fusion. And chain fusion, I think, is a very, very exciting topic. So I'm more than happy to see so many builders here today joining us. And I'm currently at EFCC. I think a majority of the Encode Club team is here as well. And at our booth at EFCC, everything's about the chain fusion summer. So this is actually the perfect time for you to get started building cross-chain applications with the internet computer as the backbone. And this is also what the bounty for this hackathon is about. So we want you to leverage chain fusion to build a multi-chain dApp. And that means that we want you to facilitate the cross-chain communication abilities that smart contracts or canisters on the internet computer have to build applications that allow to kind of like communicate between one chain and another. And for this communication, we want you to use the internet computer as basically a hub where all this communication goes through. And for this bounty, we have two prizes. So we have $10,000, like $10,000 in ICP awarded as two $5,000 developer grants. And for the first developer grant, the first batch is basically distributed immediately. So you receive $2.5K in ICP immediately, and the rest of the prize is dispersed progressively as the winners achieve the milestones that they outlined in their grant proposal. But I'm sure we are going to add more details on this throughout this Educate series and also later on when the hackathon starts. And in any case, if you have any questions around it, feel free to reach out to us or also to Encode Club, and we will make sure that everything is crystal clear. Yeah, with that, good luck with the hackathon. I'm very much looking forward to see what you guys are building. I personally think chain fusion is, I would say, actually the coolest thing about the internet computer because it's very unique and it's something that you don't really get from building on other chains. And it opens up a lot of really, really new use cases that haven't been possible before. And it also allows existing projects to push part of their tech stack that they would usually have on a centralized provider like AWS or Google Cloud or anything like that, actually on-chain, so on the internet computer. And I think that's pretty exciting. So the goal, if you already have a project, which I assume most of people do not have, but still, if you would have a project already, the goal wouldn't be to kind of like, push you into rewriting everything from scratch and deploying it on the internet computer. It would be more like trying to convince you to fill the centralized gaps that your tech stack still has with the internet computer instead. And this is one use case, so that's pretty cool. And like I said, you can also build entirely new applications from scratch. You can build programmable Bitcoin with chain fusion and a lot of very, very cool other things. Later on, we are going to dive into one of the major use cases that chain fusion enables, and that is using the internet computer as a coprocessor for EVM chains. And that, I'm not going to take away too much from that already, but I'm, like I said, very excited to be here. Very much looking forward to see what you guys are building. And with that, back to you, Yasin. Thanks for having me.
Thank you. Yes, Moritz did a quick sneak peek of what is to come in a few minutes when he goes and starts his workshop. We're just going to be following this session. Thank you, Moritz. For now, I'm going to add you on stage real quick. Right. To continue things off, I wanted to go over a few frequently asked questions that people usually come and that might want to ask. So the question is whether you want who's going to be allowed to take part of the program, and there are no requirements whatsoever. So everyone is free to register. You're free to work in teams. You're also free to be working alone. For those of you that are asking what is the best place to find the most important information for the program, if you have already registered, you will have the most important link in your inboxes, which is what we call the Hacker Pack. The Hacker Pack is a Notion page with all the most important information that you will ever need for this program, which includes a list of all the different repositories that might be of use to you, different documentations, as well as links that you might be using for the duration of this hackathon. I'm going to quickly link this one for everyone that might have lost this. I've shared the link in chat. You are free, as I said, if you've not registered yet, please make sure to do so, or you will have that link in your emails as well. Can enter an existing project, which is something that Moritz quickly just touched upon. Yes, you can, especially in the context of this hackathon. You are free to use projects that you've previously been worked on, and as Moritz said, fill in the gaps of anything that might have been centralized so far. Whether you need a team, as I said, you are free to be working on your own, but obviously we encourage you to team up with like-minded people and submit something of greater value by, teamwork. What is the most of the communication actually happen? It's going to be on Discord. This is where we're most active at, but feel free to reach out, feel free to post in the general channels, feel free to follow the announcement channels where we'll be posting the most important bits, and feel free to DM us. By us, I mean mostly me, but also any of the other Encode members. Where there's going to be, the last bit is whether you can expect some technical support. Yes, this is the whole reason why we want all of you to be really as active as possible, because the more we know what you're trying to build, the better we'll be at supporting you during your developer journey. Moving on with an overview of some of the key dates. We are obviously having the launch event right now, and we're going to move on immediately to a Moritz workshop, which is going to be on how to use the Internet computer as a coprocessor. Tomorrow, we're going to have another workshop at 5 p.m. Central European time. And don't worry about time zones, by the way. If you have already registered for the event, you will get all the invites in your calendar, so you will know exactly what the time is respective to your time zone. Tomorrow's workshop is going to be on how to integrate with SWE and SIWS. And next week, we're going to have a couple of workshops, which is going to be interacting with EVM chains using the EVM RPC canisters, and how to build cross-chain governance. In the end of the 4 weeks, once the submission deadline has passed, we will have a quick review of the projects, and the finale and prize giving event is going to happen on August 22nd. As I said, for all of these events, you will be receiving invites in your calendar after you registered. So you've not registered yet, please make sure to do so. Another overview of key dates that you want to keep in mind is we are going to do an idea submission deadline. The idea submission deadline is going to be 2 weeks after today. As of today, the idea submission deadline is something that is basically the midpoint of the hackathon. So we presume that having seen all the workshops and having attended and ideated with some of your friends, you would have an idea that you would like to develop for the second part of the hackathon, which is basically weeks 3 and 4. And the idea submission deadline, which is mandatory for everyone, is you giving us some heads up on what you want to build, and allowing us to provide you the adequate support so that we make sure that your idea comes to fruition and ends up becoming a submission. The actual project submission deadline is going to be 4 weeks from now, or 2 weeks after the midway of the hackathon. And as I said, we have dedicated forms for that. And afterwards, we will then proceed with quick reviewing and judging from the Internet Computer side. Once once the best teams have been identified, 10 finalists will be invited to do pitch practices, and these 10 teams will then be expected to attend the hackathon finale, which, as I said, is going to be on August 22nd. And some of these 10 teams will end up being the winners of the prizes Moritz presented previously. Next steps. Without dragging this one too much, join our Discord if you haven't already. Make sure you've registered from our webpage. Make sure you find some teammates. Feel free to say hi on Discord. We have dedicated channels for that as well. Let us know what you're planning to build. Let us know what your skill sets are, and somebody else might want to team up. Participate in the workshops. You will have invites for these added to your calendar if you register, so make sure to do so, and then make sure you end up submitting your project idea. By the end of the hackathon, hopefully you will have your project finished, built, and as I said, don't worry about the quality of it. Make sure you end up having a submission, and hopefully you'll be one of the 10 teams that will be selected for to pitch at the finale. If you have any questions, make sure to post them in the chat section. You'll find it on the bottom right side, and there's a dedicated questions channel. There's already a question by Maltish, who is, how can I, a dev who is currently supported by ICP dev grant, best benefit from the hackathon? Could I win another grant? Can I get better access to team support? You can always get access to team support, depending on the team that you end up working with, team composition, your idea. I think the Internet Computer team will be able to make a decision whether you will be able to apply for a second grant. I would say that you should definitely engage with the program, try and submit something, and the more the team ends up knowing what you're trying to build, the better they will be able to give you a proper advice on whether you will be applicable for a separate one. So in any case, make sure you apply, make sure to participate. Moritz is sharing a bit more details for the grants. But yeah, time to add Moritz on stage for the actual, as I said, first workshop, which is going to be on how to use the Internet Computer as a coprocessor. While Moritz is presenting, make sure to use the chat section bottom right side. He will not be able to see all of these, but post all your questions in the questions tab, and he will revert back once he's done. Let me quickly add you, Moritz, back on stage.
Hello, hello.
Hello once again. And as I said, we're jumping directly into the workshop. Moritz, feel free to share your slides, and yeah, take it away.
Okay. So maybe a more formal introduction. My name is Moritz. I'm a developer relations engineer at DFINITY. So I spend a lot of time with the grants program. So if you have any questions related to grants, you can always reach out to me and I'll try to answer them. And apart from that, I build example applications. I try to make sure that our docs are always up to date. I try to take developer feedback and forward it internally to make sure to improve our developer experience, to make it as good as possible. And today, as already mentioned, we are going to talk about how to use the Internet Computer as a coprocessor for EVMs. And before we are going to start with the practical part, we are going over some theory to make sure that we actually understand everything that we are doing later on. So in the presentation, I'm going to give you a quick intro to the Internet Computer. I'm going to touch canister smart contracts briefly, and I'm going to talk about how they are able to interact with Ethereum using the unique capabilities that they have. And throughout this presentation, there are a number of QR codes that you can scan to get further reading material, but you don't have to keep your phone out all the time trying to catch those. You can just scan this QR code once, and then you have access to the slides. And within the slides, you can actually also click on the QR codes to get to the respective resource. So I'll give you a couple of seconds to scan this, to get your phone out, and then we can continue. Okay, I assume most of the people should have scanned this by now. But if not, I can also later on share the link in the chat. You just remind me, please. Okay, as a quick reminder, the Internet Computer is a decentralized and permissionless cloud built on blockchain technology. And to add a bit more context to this, after Bitcoin and Ethereum, the Internet Computer is a third-generation blockchain. And that means that the Internet Computer solves problems that Ethereum has not been able to solve with its evolutionary step. And this means that the Internet Computer is a high-performant and horizontally scalable blockchain. And that means also that the Internet Computer is able to run very general smart contracts or even host web pages. And I want to underline the statement by quickly comparing the performance of some of the key metrics between Ethereum and the Internet Computer. For example, for transactions per second, the Internet Computer is 2 orders of magnitude more performant. For transaction finality, there's a similar picture. The Internet Computer, again, is almost 2 orders of magnitude more performant. Even better with transaction costs, the IC is way cheaper in performing a transaction than Ethereum. And talking about storage costs, that gap is even bigger, or probably similarly big, but it is big. Storing a gigabyte of data on Ethereum at the time those slides were created cost about $15.5 million, while on the Internet Computer you can store a gigabyte of data for $5 a year, so a significantly cheaper. But while the Internet Computer excels in those metrics, of course, Ethereum is also constantly improving through solutions like sharding or, which is pretty hip right now, layer 2s. And something that's not on this table is that, of course, the Ethereum community and ecosystem is way bigger than that of the Internet Computer. That's why we are at the ECC today. And also, Ethereum is proven and trusted technology that has been around for a very long time. And actually, for the use case of this workshop, we aim to combine the high performance capabilities of the Internet Computer with the security and the decentralization that Ethereum has been known for years now. So next, I want to quickly talk about canister smart contracts. So canisters combine code and state in one place. So when you deploy a canister, you actually have to first compile your code from a high-level programming language into a WASM module. And WASM, or WebAssembly, is a low-level portable binary instruction format. And in theory, all languages that compile to WASM or that have an interpreter that can be compiled to WASM can be used to write canisters. And that includes, for example, Motoko, which is our domain-specific language that has been developed and built specifically to write canister smart contracts on the Internet Computer. But you can also use Rust or Python and TypeScript. The latter two have interpreters that you can compile to WASM. So that's pretty cool, actually. Okay, so canisters. Canisters are an evolution of smart contracts as you know them. And in my opinion, it's a bit easier to think about them as decentralized servers than traditional smart contracts because they share more similarities with traditional servers. So on this slide, I want to quickly go over some of the unique features and capabilities that canisters can offer to developers. The first feature I want to mention are timers. So canisters can automatically execute specific contract logic either after a specified delay or periodically or both. So after a specified delay and after that periodically. So that's pretty cool. This is something that you would usually need off-chain infrastructure for in the EVM world. The next thing I want to mention is the reverse gas model. So thanks to the reverse gas model, the users of your application don't need to know anything about crypto, about wallets, or about tokens. So the reverse gas model means that canisters, so canister smart contracts, are pre-charged with gas to pay for the computation that users incur. And I think that's a pretty important and pretty big feature, because this is probably very important for mainstream adoption. Because trying to get your grandma to create a MetaMask wallet and do KYC on an exchange and sign transactions and everything probably is going to be difficult. And this is something that is basically taking away, that burden is taken away from users if you build on the internet computer. You most of the time probably don't even realize that you are currently interacting with a decentralized application and not with a traditional centralized application. The next thing I want to mention is the HTTP outcall feature. And that means that canisters can call into Web2 services, like, for example, an exchange rate API or RPC providers for EVM chains. And that's also pretty big. And we are going to get back to that in a little while and see how we use this in the chain fusion context or in the coprocessor context. Another very cool thing is that canisters operate at web speed. And that means that users do not have to wait a long time for a transaction to be finalized. Currently, the time to finalize a transaction is between 1 or 2 seconds, and that allows developers building on the internet computer to offer their users almost the same experience that they are used to from interacting with Web2 services. So that's also a pretty important thing for mainstream adoption. The next cool feature is that the internet computer provides a secure and verifiable way to generate random numbers directly within canisters. Again, this is something that usually within the EVM world you do not have. So if you want randomness within a smart contract, you usually need an oracle that kind of like gets randomness from some off-chain source and then writes it into a smart contract to be used within. So again, very cool feature. And now the flagship feature, the chain key signatures. So thanks to chain key signatures, canisters have control over a unique ECDSA key pair, and they can securely request signatures with the corresponding private key to be computed. And this enables canisters to natively hold Bitcoin or, for example, also Ethereum, as those chains support ECDSA signatures. And traditionally, most of the EVM chains support ECDSA signatures. So it's not only Bitcoin or Ethereum, but also, for example, Avalanche, and I think also probably most of the layer 2s. So yeah, that's a pretty cool feature. And I would say that's pretty unique in the blockchain ecosystem in general. Support for other signature schemes is also currently being worked on, with Schnorr signatures being on the roadmap, and I think they are going to be released by the end of the year. Apart from that, canisters, we touched on this briefly, can not only store data cheaply, but they can also store huge amounts of data. So right now, a canister can store almost 400 gigabytes of data, with plans to enable terabytes per canister in the future. So that's also something that's very unique, I would say. Not only the price, but also the capabilities or the amount of storage that a single smart contract or a single canister can use. And then, last but not least, canisters can serve websites and answer API requests over plain old HTTP. And this makes it extremely easy for developers and also for already existing Web2 applications to integrate with canisters. And it also allows you to deploy your dApps tech stack 100% on-chain without any cloud involved to serve a front end. So that's also a pretty strong feature for going 100% on-chain on the IC. Okay, so now that we know about the unique features, let's explore how canisters can leverage them to interact with Ethereum. And the first thing I want to mention here is the HTTP outcall feature that we touched upon in the previous slide, because this feature allows canisters to read Ethereum state. And to do so, as depicted on this slide here, they make an HTTP out call to an RPC provider with their request, for example, to get the logs for an event. And the result of this request is then becoming available in the canisters execution context. So that's pretty strong, and it allows canisters to read state from Ethereum. But they cannot only read Ethereum state, they can also write Ethereum state. And this works by leveraging the chain key signatures that we mentioned earlier, and here in particular, a threshold ECDSA scheme. And for this, the canister creates the transaction, for example, in Rust using ethers RS or Alloy, and then it signs the transaction using this threshold ECDSA signature scheme. And now the last thing we have to do is that we have to get the signed transaction somehow ingested into the EVM chain. And that is being done by, again, leveraging the HTTP out calls to send the transaction to an RPC provider for that EVM chain. And through this, canisters on the computer can trustlessly interact with an Ethereum smart contract. So that's pretty cool. But because building a canister that securely and correctly interacts with Ethereum can be a bit challenging and a bit tedious, we provide the EVM RPC canister for that. And that canister basically acts as a gateway to Ethereum and other EVM chains. So it's kind of like a helper canister that does a lot of the heavy lifting for us. And it allows the developers that want to leverage this technology to focus on their actual use case instead of replicating the necessary logic to interact with Ethereum over and over and over. And some of the things this EVM RPC canister does for us are that it calls multiple RPC providers using HTTP out call, and then it checks that the responses that are coming back from those RPC providers are consistent amongst them. And this reduces the risk of centralization. If we imagine we only call a single RPC provider, for example, Alchemy, and there's a hack or something, or a malicious employee or whatever, then that would be quite bad for your application. So by calling multiple RPC providers, we mitigate this risk of relying on a single RPC provider. And what it also does is that this EVM RPC canister provides convenience methods that we can call without having to assemble the actual JSON request for the RPC provider. So usually when you interact with an EVM chain, the request that you are sending to the RPC provider is a JSON, and assembling this in Motoko or Rust can be a bit cumbersome. So those convenience methods, they just take a candid argument. So it's really easy to talk to EVM RPC providers through this EVM RPC canister. And of course, also the response from the RPC providers is encoded in Candid, which is our interface description language, instead of you receiving a JSON. And this makes the responses immediately useful in the context of a canister without having to deserialize the JSON into something that you can use first. So now that we have the theoretical knowledge that we need, let's talk about what we want to build. And the project that we are building today boils down to using the Internet Computer as a coprocessor for Ethereum, but in theory, you can use it for any other EVM chain that is supported by the EVM RPC canister. So, as you might know, Ethereum smart contracts are very constrained computing environments, and so-called coprocessors enable to extend the capabilities of Ethereum by offloading specific tasks to a more powerful environment. So a coprocessor could, for example, calculate some complex numerical function that wouldn't be possible to calculate on Ethereum or any other EVM chain, or too expensive. It could also run maybe cryptography like AES or RSA algorithms, or, which is actually a use case that we built that I can share later on if we have time. We can generate and store the NFT assets and the metadata for ERC-721 Ethereum NFTs within a coprocessor. And we can also make them dynamic, and that is that the actual metadata and the actual image are changing depending on some on-chain actions or activities without there having to be a centralized party that kind of like triggers the change in the metadata or the change in the asset. So this makes dynamic NFTs trustless, which is also something I think that hasn't really been possible before. So let's go through an example flow here. And that starts by the Ethereum smart contract signaling that it needs co-processing by emitting an event with details about the job that it wants done. The ICP coprocessor canister then regularly fetches logs or events, I'm going to use those two words interchangeably, through the EVM RPC canister using timers. So every X seconds, it asks the EVM RPC canister, hey, are there new events that I haven't seen yet? Or are there new logs that I haven't seen yet? And upon seeing such a job event or job log, it then runs the requested job from the EVM smart contract. And during processing the job, the canister can do many things. It can store data in the canister smart contract. It could make a cross-chain transaction on another chain, for example, trigger a transaction on Solana or on Avalanche or whatever. It could call other canisters either in the same subnet or in another subnet, and so on and so on. So basically, you're very flexible in what you do during this processing. And if needed, the result of the computation, the result of this processing can be written back to the Ethereum smart contract. And for this, as we mentioned earlier, the canister creates a contract call to a callback that is a callback endpoint that is offered by the EVM smart contract. And it then signs it with threshold ECDSA and sends it to the EVM network through the EVM RPC canister. And in this callback function that is exposed by the EVM smart contract, we assert that the caller is the coprocessor canister. So as I mentioned, canisters have access to unique ECDSA key pairs, and that is they also have a public key, and that is they also have an address. So we can make an assertion that the caller of this function is a certain address, so we can make sure that only the coprocessor canister can write results back to the EVM smart contract. And because this coprocessor architecture is very versatile and can be leveraged for a lot of different use cases, we actually provide a template repository for this. And this is called the Chain Fusion Starter. In the starter, the coprocessor logic is, of course, already implemented, and the developer only needs to worry about what computation they want to carry out for a specific event. And this coprocessor canister or this Chain Fusion Starter project leverages the EVM RPC canister to interact with Ethereum, and it also ships with a dev container, which is basically a Docker image that has all the dependencies that you need for building on the internet computer, for building coprocessors on the internet computer, pre-installed for minimal friction, so you can start building right away. And of course, this is what we are going to use as a starting point for today's workshop. So you have two QR codes here. The first one is the Chain Fusion Starter. You can also follow the link down below. And the second one is the outcome of today's workshop. If you don't want to, or if you want this as a resource for later on, or I don't expect people to code along. You could in theory, but sometimes I just copy paste code because it would take too long to write it out. But nonetheless, in the bottom QR code or in the bottom link, you can find the outcome of today's workshop. So the plan is that we are going to today modify this template, this Chain Fusion Starter, to carry out a different co-processing duty. And the plan is that we are going to fetch the current BTC rate in US dollars from the exchange rate canister, which is a canister that provides, as the name already suggests, the exchange rate for fiat currencies and cryptocurrencies currency pairs. And then we want to write this current exchange rate back to the Ethereum smart contract. So we are basically building a Bitcoin price oracle using the internet computer. And if we have time, I'm also going to try and explain this NFT dynamic, fully on-chain NFT use case that I mentioned a couple of slides earlier. And for this part, please feel free to ask questions while I code along. I only have, because I'm at a hotel room right now, I only have one monitor, so I won't be able to check the chat or the questions section. So maybe Yasin can help me out and kind of like raise his voice whenever there's a question that fits the current context of the workshop, and then I will try to answer that while we are at it. If not, I will just try to answer it in the end. Okay. So now I have to share a different tab. Yeah, I think you should see the GitHub now. Yeah, that looks good. Okay, so this is the
Just want to add one thing while you were still moving between everybody that is thinking, oh, I missed out the QR code. Don't worry about this. We will take all the slides from Moritz, and all of them will be added to the Hackathon. So those of you that are missing out on something, don't worry about it. All of these sessions are recorded, and we will be adding the recordings as well as the slides to the Hackathon, so that you can watch at your convenience, however time you edit as many times as you would like. But yeah, back to you, Moritz.
Okay, awesome. Yeah, I can also try and share the link from today's slide later on, so you can have a look at it asynchronously. But yeah, so this is the ChainFusion starter template that I mentioned. So we're going to click on this use this template button. We're going to create a new repository. We are going to pick me as an owner. We are going to call this Encode. This can stay private for now because you have the public resource anyways. And now we are going to create the repository. Before we start, I quickly want to walk you through this starter template. There's actually a pretty detailed README that you can also take a look at after today's workshop. And I mean, this part we already covered. So we already had an overview. You know what a coprocessor is. You know why you should use the internet computer as a coprocessor for Ethereum or the EVM. And this is getting started. We don't know that. And now we can take a quick look at the architecture. So as I mentioned, there are basically 3 contracts involved here. 2 of them are deployed on the internet computer, and one is an EVM smart contract that emits events when a specific function is being called. So yeah, maybe let's go through them. So like I already mentioned, there's an EVM smart contract that's deployed on Ethereum that emits new job events when you call the create job endpoint. We will take a look at the smart contract in a little while. And it also handles callbacks from the ChainFusion canister with the results of the processed jobs. Then we have the ChainFusion canister, which is basically implementing this co-processing logic. So it regularly fetches events emitted by the EVM smart contract. Then it processes them and sends, if needed, the result back to the EVM smart contract. And then we also have this EVM RPC canister, which is this gateway to facilitate communication between the internet computer and EVM chains. So we can take a look at this sequence diagram real quick. I hope this is kind of visible. So yeah, the whole sequence starts by the EVM smart contract emitting an event. And then every 180 seconds using this timers functionality that we learned about earlier, the ChainFusion starter asks the EVM RPC canister for the block number of the latest finalized block. The EVM RPC canister then makes the actual RPC calls, sending JSON requests to a number of RPC providers. It receives a response from each one of the RPC providers, and then it checks if they are consistent, and if so, it sends the result back as a candid response, which is pretty neat. We then update internally in the Chain Fusion starter the last observed block to the basically block number of the finalized block that we just received. And now we are going to ask the EVM RPC canister for locks in a specific topic using a range specified as the from block and to block argument. So we basically ask for events in the range of the last block that we scraped, that we looked at, and the latest finalized block that we just received. And yeah, this way we sequentially move forward as the EVM chain grows, and we are always getting access to the latest blocks that have been events that have been emitted by the smart contract. And here again, the EVM RPC canister makes HTTP outcalls to different RPC providers. It receives the events for this block range. It checks the events for consistency and then provides them as a candid response back to the Chain Fusion starter. And here again, we update our last scraped global variable so that next time we basically continue scraping where we ended. So we are not asking for the same range twice. And the Chain Fusion starter then, for each event or for each log that it receives, carries out this job, this co-processing. And if needed, it writes the result back to the EVM smart contract, but this is not depicted in this diagram. I just realized that you probably, yeah, I didn't share the right tab, but I mean, it was still visible, so I think it's okay. But in the other tab, I was actually moving my mouse along, but I hope it was kind of visible. If not, maybe let me quickly check the chat. Yeah, no one complained, so I would just assume that this was good enough. All right, so let's actually take a look at those three contracts. So the first one is the EVM contract that is in contracts and then coprocessor. And it's very simple. It has a global counter that depicts the job IDs. And it has this new job function that you can call. You have to send 0.1 Ether with the call to pay for the computation that the coprocessor does for you, and also for paying for writing the result of this co-processing back to the EVM smart contract, because this is a transaction and transactions cost gas or cost ETH. And if this assertion here checks out, it transfers the attached 0.01 Ether to the coprocessor canister and then emits a new job and increments the job counter. This is the callback that I mentioned. So this is basically to write the result of the computation back to the EVM smart contract, and this can only be called by the coprocessor. And when deploying this contract, we pass the address of the coprocessor as a constructor. And then we have this get result endpoint that allows you to get the result for a specific job ID. And now we have the Chain Fusion canister code, which is written in Rust. And in here, we are only interested in this job module, basically. And there's nothing crazy going on here. What it does is, upon seeing an event, so basically upon a new job being created or emitted from the EVM smart contract, this function here is being executed, this job function. And it does nothing but calculating the 20th Fibonacci number, which is a calculation that you wouldn't be able to perform on an EVM because it would most likely exceed the gas limit. And then it writes the result of this computation back to the EVM smart contract using this submit result function here. So let me quickly check if this covers everything. Yeah, then we also have this script here, which basically deploys the EVM smart contract. So there's nothing crazy going on that you have to be aware of. It just passes the chain fusion's canister, the chain fusion canister's Ethereum address as an argument, as a constructor, as I just mentioned. And what it then does is that it automatically creates 3 new jobs. So it calls the new job method or function exposed by the coprocessor smart contract 3 times, each time attaching the required 0.1 Ether. It's actually more than needed, I just realized, but yeah, not a problem. The more, the merrier. Yeah, and that should be it. Let's quickly go back and see. So we had this, we talked about this, we talked about this. In general, down here are a couple more sections. So there are a couple more features that we're not going to talk about. I would advise you, if you are interested in using this, that you read the entire README, because there is some more information in here. And also down here, there are some examples that leverage this starter logic. So on-chain metadata and asset creation for ERC-721 NFT contracts, what I mentioned briefly, but a couple of other things. And if you are looking for ideas to explore, you can find a number of things you could build with this down here. And last but not least, there are additional resources. So there's another recorded workshop, or 2 more workshops recorded from DebCon and from ETH Prague. So if today's workshop is not enough for you, this one, the DebCon one, is very thorough, but also quite quick. And yeah, it gives you a good idea on how to leverage this starter in a more sophisticated way than what we are doing today. Okay, but what we are going to do now is to use one of those code spaces or dev containers. So basically a working environment that's running in the cloud that I can SSH into with my Visual Studio installation. So I'm going to click on this 3 dots here, then new with options, because I want to pick a beefier than the standard setup. So I'm going to go for the 16 core thing. And this opens up an editor in your VS Code, in your browser, a VS Code editor in your browser, but I don't want to use that. So I'm going to go back, and I'm going to connect to this using my local Visual Studio Code installation. And this should open Visual Studio Code now. So I have to share a different screen. Let's see. Somehow this is not available to share. Now it is. Weird. Okay. You should be able to see my editor now. Yeah, that looks good. Okay. It's a bit complicated with a single monitor setup, but we are getting there. Okay. Yeah. Okay, yeah, this worked. Yeah, so as I said, the plan now is to, let me actually, I already did that. So yeah, we are now going to replace this, actually, let me maybe, is the font okay? The font size okay like that? Or do you want me to increase it?
Yes, I can perfectly read it, but maybe, if you zoom in just a tiny bit, like just
okay,
once, I think should be quite clear. Yeah.
Okay, awesome. Yeah, so the goal is to replace the logic in the job, this Fibonacci here, with fetching the current Bitcoin price in US dollars and then writing that back to the EVM smart contract instead. So basically building a price oracle on the internet computer for an EVM smart contract. And to do that, we are going to get the Bitcoin rate or the Bitcoin price by making an intercanister call to the so-called exchange rate canister. And now I have to share a different thing again. Wow, this is more complicated than I anticipated. Let's see. So instead, yeah, this is the right one. So this is the repository of the exchange rate canister. And as this about section here says, the exchange rate canister makes use of the HTTP request feature to provide exchange rates as a service to the internet computer. So similar to the EVM RPC canister, it doesn't only call a single aggregator to get a price for a certain asset, but it calls multiple data providers. So it doesn't only call, for example, CoinGecko, but it calls CoinGecko, Crypto.com, maybe some central banks, and so on for the rates of different assets. And then it aggregates them and makes sure that they do not deviate too much. And that's a pretty safe approach to get the exchange rate for assets. And this is actually what is being used by the cycles minting canister to determine the rate at which cycles are minted when you burn ICP to create them. So we use this as well. The internet computer basically relies on this service canister. And this is what we are going to use to fetch the Bitcoin price. And to do so, we first are going to modify our dfx.json to actually add the EVM, the exchange rate canister. So again, I have to share a different screen. Okay. So in here, this dfx.json basically tells or defines what canisters are deployed locally. So in our case, we have the JFusion canister. So we know that we've seen this in the overview. We have the EVM RPC canister. This is our gateway. And now we are going to add another canister, which is the exchange rate canister, so XRC. And this is also of type custom. We provide a link to the candidate. Actually, yeah, I think I'm going to just share my notes for the workshop as well, because it takes too much time to disable and enable screen sharing all the time. So I'm just going to share my entire screen now. You get an insight into my notes as well. But yeah, okay, that looks better now. Yeah, so how do we get those entries here? How do we get the link to the candidate? How do we get the link to the WASM? We get those by going to the releases. And in here, to get the actual WASM file, we can just copy the link address from this asset. So this is the compiled canister, the compiled canister WASM. And this is what we use for the WASM entry here. And for the candidate, which is like the interface description, it's a bit more complicated. So we go up here and we actually click on this commit hash, and then we click on browse file, so we can take a look at the repository at the point in time where the release was created. Then we're going to source, to XRC, and then to xrc.dit. And this is the dit file at that point in time. Then you need to click on raw, and then you can take the link up here and paste it into this candidate field. And this is what I did. The next one is remote. This basically tells DFX what the canister ID is when you deploy on mainnet. And to get this information, we can again go back to the repository of the exchange rate canister. We scroll down a little bit and we see here, okay, this is the principal or the canister ID deployed on mainnet, but you could also get it from this canister IDs.json file if you check XRC and then the IC entry here. And because we want to keep things consistent, we are saying to DFX that we want to deploy this canister locally under the same canister ID. So again, we specify this ID that the canister is deployed under on mainnet. And that's it for adding the canister to our project. And now, because in reality, the exchange rate canister is deployed on the system subnet, on an NNS, on the, I think it's called a system subnet actually. We have to add this specification to our DFX, so that when DFX spins up a local replica and spins up a local copy of the internet computer, it doesn't spin it up as an application subnet, but it spins it up as a system subnet. There are a couple of subtle differences between system and application subnets, and one of them is that on a system subnet, canisters do not need to pay cycles for HTTP outcalls, and the exchange rate canister is built in a way that it relies on that fact. So if I were to deploy this on an application subnet locally, all the calls would fail because it would always say, hey, I need cycles attached to make this HTTP outcalls, but there are no cycles attached. So yeah, we have to change this networks.json file. And because there's no editor installed in our Docker image, I have to use this hacky way of using cat to write this file. So now I can copy this part here, which is basically the way this file needs to look like. So this basically tells me, or tells DFX, if you start a local replica, the subnet type of this replica, or the subnet type that you spin up should be a system subnet. And I can write this by pressing Control D. And now I can check again if this actually has been written by just catting the file, and it looks good. And now there's one thing I haven't mentioned yet, and that is this deploy script here. And this basically takes away of you writing all the commands that I needed to get this whole thing running. So it deploys, it starts a local Ethereum instance. It then starts an HTTPS proxy, which you need to make HTTP outcalls work against an HTTP endpoint instead of HTTPS. And it then also starts DFX, and it deploys all the canisters. And then it also runs this deployment script for the EVM canister that I shared with you earlier. So it deploys the EVM smart contract, this coprocessor smart contract, and it then calls the new job endpoint 3 times, as we've seen in the script. So far, we only deploy the chain fusion canister and the EVM RPC canister, but now we also have to deploy the exchange rate canister, of course, because we need that as well in our architecture. Okay, so that should be it about adding the exchange rate canister to our project. And now we are going to add the Rust bindings for the exchange rate canister. So the exchange rate canister is actually pretty simple. It only has a single endpoint, and that is called get exchange rate. It takes get exchange rate request, one get exchange rate request argument. That's a tongue twister. And it returns a get exchange rate result. And be aware of the note down here. When you call the exchange rate canister, you have to attach cycles to that call. So you have to pay the exchange rate canister to actually give you the exchange rate. And that's going to be important later on. So we can take a look at the candid file, which is basically the interface description of this canister. So what kind of methods does it offer, and what types what argument types and what response types do these methods have. So it's like an ABI for the equivalent of an ABI for EVM smart contracts is our candid or DIT file. And in here, as you can see, the service here offers one endpoint, get exchange rate, and I already mentioned this. So now this is candid, right? So when we are using Rust, so if I wanted to make the call to this canister, I would need to kind of like translate the candid arguments here into Rust. And that would be a bit tedious to do now. So we are going to use a little trick here. We are actually going to head over to the dashboard, and we are going to enter the canister ID of the exchange rate canister deployed on mainnet in the dashboard. So we're going to search for that. And as we can see, the exchange rate canister now pops up. And down here, the canister interface is replicated, but it's not only available as a candid file, but actually also as Motoko, Rust, JavaScript, and TypeScript bindings. So I do not have to replicate all the types, the candid types in Rust. I can just copy, paste this thing here. And this is what we are doing. And now to interact with this exchange rate canister, we're going to add a new module that we call XRC, so exchange rate canister.rs. RS is the file ending for Rust. And we're just going to copy paste this here. And now you can see this is grayed out because the project is not aware that this file exists. So I have to add the module to my lib.rs file, which basically exposes xrc.rs to all the other modules that are part of this project. Yeah. So now you can see this is not grayed out anymore. And down here we have this service struct that is being exported. And this allows me using a dot notation to call service.getExchangeRateCanister, and then I can provide the arguments with the correct types and I get the result with the correct type. But one thing here is missing. If we go back to the exchange rate canister README, we have to attach cycles, right? And right now, the call that we are making here is a simple call. It doesn't attach any cycles. So we have to actually change the way that we call the exchange rate canister. So we're going to use API call and then call with payment. And we are going to use the call with payment 182. And this allows us to pass in cycles as an argument that we want to attach to the intercanister call that we are making. So first, I'm going to add a cycles argument of type U128 to my overall implementation of the service, so to the get exchange rate method. And then, of course, I'm also adding this to the call with payment method down here, and it's the last argument. So this should work now. So let's go back and check if we have everything. So we have the Rust bindings, we created this file, we changed the service to be able to actually send cycles with the call, and we made XRC available in lib.rs. So now we can actually start modifying the job, right? So in here, I said that we are right now just always calculating the 20th Fibonacci number. And if we check where this function comes from, we can see that this comes from another module called calculate results. So if we go in the job folder up here, we can find this module. And within this module, there's also this implementation of the Fibonacci function. And we're going to delete that. And we are going to replace that with what I've written here already. So this is the point where I again copy paste, because it would take too much time to write this out, but I'm going to explain what is happening. So we have a new asynchronous method that we expose that is called get exchange rate. This function doesn't take any arguments, but it returns the exchange rate, which is a struct. The struct is basically like an object, and this has a couple of fields. For example, the rate, a timestamp, the quote asset, the base asset, and some metadata for the exchange rate. So the first thing in this function that we are going to do is that we are going to basically instantiate this service struct. And this takes a principal, and that principal is the canister ID that we want to call. So we are basically saying, if you call this canister, it exposes the methods that are defined in this service struct. So basically this single method that is called get exchange rate. So this is what we do here. So this XRC variable is of type service. We're going to see this in a little bit. Now we're going to define the amount of cycles that we want to attach to the call. And if you remember from the README, those are 1 billion cycles. So we define 1 billion cycles here. And now that's the nice thing, we define the, instantiate the get exchange rate request struct. And this is just imported, right, from this copy-pasted Rust bindings that we got from the dashboard. So I don't have to type all the types, they're just there, and I can just fill them in with the values as needed. So the argument that is taken by the get exchange rate method is an get exchange rate request. So this is what we create here. This is the request. And we say we don't provide a timestamp, we want the latest data. Our base asset is a cryptocurrency, and in that case, it's Bitcoin. And our quote asset is a fiat currency, and in that case, it's United States dollars. And now we can actually make the call, the inter-canister call to the exchange rate canister. And this is super easy now because we just use the dot notation, as I mentioned earlier. So on this XRC variable, we call the get exchange rate method. We provide our request, which is already beautifully typed without us having to write anything. We provide the amount of cycles that we want to attach to this call, which is 1 billion as specified in the README. And now we match what is coming back. So either there's like basically a system error, then we trap. Usually in production, you shouldn't do that. Or the call went through, then we match again because the exchange rate result, if we go back here and we actually check exchange rate result, it can either be okay or there could be an error that occurred. So again, in here we have to make another match, and if the exchange rate is okay, we just return it, and if not, again we trap. So like I said, you shouldn't do that, you should handle the error, but for the sake of this tutorial or this workshop, we are just going to trap. All right, so this explained everything. And the last thing we have to do now is to go back to our job, which is, of course, now containing an error because we deleted this Fibonacci function. So we are going to replace this with get exchange rate. So down here, we are also going to call get exchange rate. This doesn't take any arguments, and it's asynchronous, so we have to await it. And now the result here is of type exchange rate. And we only want to write the actual Bitcoin price in dollars to the smart contract. But this exchange rate here, if you look at it, right, it contains a lot of fields. So what we have to do now is we have to take the rate, which is a U64, and we also have to take the metadata. In this case, we have to take the decimals, and this tells us from the rate how much of the symbols that we see are actually decimals, so that we can set a point at the correct at the correct symbol or at the correct number. That might not have been the best explanation, but it's just to get the right number, the price in dollar that we expect. And for this, again, I'm just going to copy paste this here because it's easier than writing it out. It's a bit error prone. So we basically take the rate and we specify where to set the decimal point for the rate. And then we are writing the result back to the EVM smart contract using this submit result function. If you're interested in how that works, you can check it out here. It's pretty, maybe not too straightforward, but the heavy load is taken away by the starter template. So it's easier than it would have been without a starter template, let's put it that way. Okay, and now, we should be able to actually run our deploy script to demo that this works, right? So let's try the deploy script. So like I said, this starts a local EVM instance. It deploys the EVM smart contract there and makes 3 calls to the new job method on the EVM smart contract. And it also deploys the EVM RPC canister, the exchange rate canister, and of course the chain fusion canister. And then once the chain fusion canister has been deployed, every 180 seconds, the chain fusion canister asks for the latest block, the latest finalized block, and then uses that information to get locks in a block range from the EVM smart contract. So we have to compile this first. This takes a little while. Yeah, maybe I can actually show this again. So yeah, deploy EVM RPC, deploy the exchange rate canister, build our WASM, then create a new canister with enough cycles so that we can pay the EVM RPC canister and the exchange rate canister. And then we are installing the chain fusion canister with a number of initialization arguments that you do not need to understand right now. But if you want to understand them, make sure to read the code. It's pretty straightforward, I would say. And then we get the EVM address from the chain fusion canister, and we pass that as an argument to the deployment script for the EVM smart contract, so that the EVM smart contract can assert that the caller of the callback, so to write back the results, is actually the chain fusion canister and no one else. So down here you can see a number of logs that have been printed. This basically is the block. And now it complains a little bit because some of the endpoints to receive an exchange rate are not working properly. But I think, at least when I tried this earlier, we had enough responses to get to consensus and to write back the result to the EVM smart contract. And what you see here, this is the chain fusion canister. So our coprocessor sending a signed transaction to the EVM to basically write the result of this co-processing logic, of this job of getting the Bitcoin US dollar exchange rate back to the Ethereum smart contract. So this is what you see here. And at some point there should be this output here, which is successfully ran job number 0. So this tells us, okay, everything worked. And you should do this 2 more times. So again, this is the second transaction to write state back to the EVM smart contract. So what I mean by writing state back to the EVM smart contract, this is the chain fusion starter canister calling this callback function here with the actual exchange rate of Bitcoin. So it writes the calculation, it writes the Oracle data back to the EVM smart contract, and it has to do this by signing a transaction and sending it to the EVM. Otherwise, you cannot write state, right? You need a transaction and you need to sign it. And that's very cool, very unique. And as far as I know, only possible on the IC. But yeah, let me actually show this in action. So if we go back to our starter template here, we can see that there is a section that says, read from EVM smart contracts. And we're going to head over there. Okay, the link is not working. Good to know. Have to improve this. Where are we? Here. Development. Yeah, interacting with the EVM smart contract. So we can use this command here to read state from the EVM smart contract. And what it does is it uses CAS, which comes with Foundry. Foundry is basically the tool chain that we use to develop the Ethereum smart contract. And CAS call means basically like read state from a contract. And in this case, this is the contract. The contract is hard-coded, so you can just copy-paste it. It's always the same. And then we specify what we want to call. We want to call the get result function here, defined. And this takes an unsigned integer and returns a string. And the unsigned integer is the job ID. So we want to get the basically value that has been written for the first job. So this should be the exchange rate of Bitcoin. And as you can see, it's there. It's $56,141 and a bunch more. So we can check if this changed over the maybe 30 seconds in between processing those jobs. But last time it didn't. So Bitcoin price was stable for 30 seconds. Oh yeah, here it changed. Okay, so for the last call, there was actually a difference. So it rose by, wow, $9. Not too bad. Okay, and that concludes the workshop. It took longer than I thought, actually. Let me go and share the final slide here. And that is, if you have questions or if you need help, the first one that is also linked in Encode Club's resources is the Hackathon cheat sheet. It contains a lot of information. I would definitely recommend you to bookmark this and keep it open at all times. The second link or QR code is our community-led Discord channel or server that you should definitely join, where you can ask smaller developer questions. There's an Ask Questions channel in there as well. Then we have the developer forum. This is a place to ask more complex questions where you expect the question itself to be longer and also the answer to be longer. Then I want to highlight the fact that we have developer grants. So even if you do not win one of the bounties, you should definitely think about applying for a developer grant. They start at 5K and all the way up to 100K. So definitely check that out. The last one is the previous Educate series that we did with Encode Club, or the previous, which is the Intercomputer Protocol Demystified. You should definitely also check that out if some of the key aspects of the IC are not clear yet. So it's, I think, 6 sessions that go deeply into the protocol and how everything works. It's a very, very good place to start from a theoretical point of view. So you make sure you are aware of all the capabilities the IC offers. And then there's also a resource called the Intercomputer for Ethereum developers. This is like a wiki article with differences and similarities. Also definitely recommend you to check that out. And then, of course, the latest Encode Club Educate series about chain fusion. It's not on the slide, I just realized that, but you should find it on the Encode Club YouTube channel. It's also a very, very good resource, and I would definitely recommend you to watch this before you start actually building. I know 4 weeks is not that much, but all in all, I think it's like maybe 10 hours of your lifetime, and then you are very well prepared for everything that is going to come in your developer journey. And yeah, let me stop sharing my screen. Or maybe I should actually share it so you can, if you need, scan the codes.
You can go through the questions if you want. There's a couple by Maltish in the questions chat, in the question section, sorry.
Mm-hmm. How can I catch a RPC call returning different results for the different nodes in the intercomputer? I think this causes problems with my canister. That's a good question. It depends a little bit on your architecture. So if you use the EVM RPC canister, to my knowledge, this should be handled by the EVM RPC canister. If you use plain RPC, HTTP outcalls without the EVM RPC canister, then you would need to make use of the transform function. So maybe I can, wait, I can share my screen again. Entire screen. Okay, so if you go into the documentation, actually, I'm not entirely sure where this is. Yeah, that's a transformation function that you can use. And you can use that to make sure that the responses that, as you already realized, are or tend to be different from node to node can can be modified in a way that their essence is the same across nodes. To give you a quick example, if you, for example, want to get the historic Bitcoin price from a year ago using HTTP outcalls, then every node in the subnet makes the same HTTP outcall to whatever data provider you are calling. Let's take CoinGecko, for example. But CoinGecko, the price at that point in time is the same because it's like fixed, right? It doesn't change. The historic price stays the same. But what is different for each of the responses that you receive is that CoinGecko might, for example, use Cloudflare, and then for Cloudflare there are a lot of like unique headers that are attached to the HTTP response. So what you usually do is that you strip away everything that you are not interested in, and in this case you strip away the headers, and you only focus on the data that you need, and that is the price of Bitcoin at that point in time. And then all the nodes in that subnet where you make the HTTP outcall from, they pass the response that they receive from CoinGecko into the transformation function that you define. And in your transformation function, you would strip away the headers, and you would only basically emit the actual Bitcoin price, and that should be the same across all the nodes in the subnet. And then they can agree on that response that they receive and pass it up to your canister to be consumed. And yeah, long story short, take a look at this transformation function here and make sure you implement it in a way that you remove all moving parts from an HTTP response. And yeah, we're using the EVM RPC canister. If you use the convenience methods, it should be taken care of for you. If you are using the...
he is using the EVM RPC canister. He even linked the error he's receiving in chat. If you want to have a look.
Yes. Mm-hmm. Mm-hmm. Yeah, that's a good question. Yeah, the problem is probably that so I was actually thinking, I mean, this error you cannot, if this is what you receive from the EVM RPC canister, you obviously cannot handle it because it's at the HTTP outcall level, right? So that's a good question. What I would recommend you to do is to join the session where we talk about how to use the EVM RPC canister, because in this session, the people that implemented this canister are going to be present, and this would be a very good question for them. If you don't want to wait for that session, this is also a very good question for the forum. So this is something that other people will probably run into at some point in time as well. I do not have the solution to this right now. So I would actually recommend you to ask this in the forum. So the URL is forum.dfinity.org, and you can tag Ryan Vandersmith. And yeah, I think Ryan should be the best person to ask. But also there's another guy, I forgot the name, one of my colleagues, so many, but he's going to lead the workshop. So it's not Ryan leading the workshop about the EVM RPC canister, but his colleague is also very deep into the code of the EVM RPC canister and how its internals work. So I'm sure he's able to help you out as well. And if you haven't checked it out yet, there is also a section in the documentation that has been constantly updated. So not this Ethereum, blah, blah, blah. Yeah, this section here, the EVM RPC canister. And I think, if I'm not mistaken, in one of the sections, probably here, there's also no, that's already known. Too few cycles. RPC result consistency here. Yeah. HTTP outcalls performed in the request method only reach consensus if the JSON RPC response is the same in each call. If you encounter an issue with consensus, please let us know, and we will look into whether it's possible to add official support for your use case. So this is probably what you need to do. I think I don't have a solution for this right now, but clicking this link, which leads to the GitHub repository of the EVM RPC canister, is probably a good idea. You can open an issue, but also please, I encourage you to ask this on the forum, because it's a very good question and something we should discuss further and think about further. Let me quickly check if there's another question. The corpus is basically an indexer plus cron. Yes, basically yes, but in the current implementation, I mean, it fetches the logs, but it's not kind of like persisting them, right? It's just storing them until it processed them, and then it just discards them. So there's no, this is my understanding at least of an indexer, that it would somehow like give you access to all of the logs, but that's not the case basically. A comment from Ali, OMG, so many canisters. Yes, many canisters, but that's also cool about the internet computer, right? You can make inter-canister calls, and the case with the exchange rate canister and the EVM RPC canister, and probably the canister that you are going to deploy in mainnet, they are all on different subnets, and this shows how easy it is to have cross-subnet communication. You basically don't even notice that the canister is on a different subnet. So I think it's pretty cool that you can build many different canisters with many different tasks and let them all interact with each other. And this is actually also the vision that the internet computer was built around. So it was built around the actor model, that you have different actors that pass around messages and act on them. So yeah, for me, that's cool. Okay, I think there was one more question. No.
Yeah, it was in the question chat, also from Maltish.
Yeah. How can I, a developer who's currently supported by an Internet Computer Developer Grant, best benefit from the hackathon? Could I win another grant? Can I get better access to support? Anything else? So that's actually a good question. I feel like, I mean, during the hackathon, you, I would say, get pretty good support from people working at DFINITY, and at the same time from people working for Encode Club. So that's a benefit. If you are kind of like maybe adding a new use case to whatever you're building as part of your grant, this is something you would benefit from. I think you could also win another grant. As mentioned in the bounty requirements, you would need to prove that what you are building as part of the hackathon doesn't overlap with what you already received a grant for. So we cannot like basically give you a hackathon prize for what you already received a grant for, right? I think that makes sense. But you could, if this is not part of your current milestones, win another grant. At least this is how I interpret it. Maybe double check with Encode Club or one of my colleagues that have a better insight into the structure of the bounty prizes. Can I get better access to support? So usually, so we cannot kind of like handhold projects, as harsh as that might sound. Your best guess at getting support is usually always the forum and the developer Discord. So this, I would say this is monitored pretty good. And if you feel like you do not get an answer, feel free to reach out to me and say like, hey, I made this post, no one's answering, then I will make sure that internally someone is taking a look and you receive the answer that you need. For some teams that we interact with closely, we have other means of supporting them. So I would assume if your grant ends up going well, and you have the need for more interaction with the foundation, then it should be able to set up a communication channel that is a bit more exclusive, let's say, where we would be able to loop in a number of people working in the foundation to help you on the issues you might have. But in general, within those, let's say, more streamlined one-to-one channels, we still encourage the developers to ask their questions if it makes sense in the forum, because that way everyone learns from the answer. And also we can train our ask, where is it? Here we have this AI, the Internet Computer Docs AI, and it's actually being trained on the forum as well. So if you if you ask a question on the forum, you receive an answer, then other people using this LLM on our website can benefit from the answer as well. Long story short, yeah. And I think that's it. No more questions. Yeah. Matthias asked, not entirely related, but ED25519 support soon. Is this Schnorr? It's not Schnorr, right? I think this is what Solana uses, ED25519. Yeah, I think it's a signature scheme that Solana supports, if I'm not mistaken. But let's see what Matthias writes. And Stellar too. Okay, so Solana and Stellar used it. So I mean, currently Schnorr is being worked on, but I know that other signature schemes that are able to be run as a threshold signature scheme are considered as well. And of course, Solana is a very big network with a lot of developers and a lot of attention. So I wouldn't be surprised if this would maybe be one of the next candidates after Schnorr has been supported. So I think right now it's not on the roadmap, but it could be soon. Okay, I think there are no more questions. So I can disable my screen sharing as well. And let me quickly share the code, the link to today's presentation. That should be done.
Having these on screen would be a perfect screen to end this workshop on.
Yeah. So there we go. Put it in the chat. Okay, yeah. And in there you find all the other links that I opened. I mean, for the exchange rate canister, you need to Google it or search it on GitHub, but all the other stuff should be in there. If something's missing, please let me know, then I'll provide it.
Perfect. With that being said, thank you, Moritz, for the amazing workshop. I think there were a lot of details that were shared. Definitely, I thank you, everybody. As I said, this is going to be is already recorded, and we will be uploading the video tomorrow. So in less than 24 hours, you have it available. You will be able to rewatch and redo some of what Moritz showcased. If you have any questions, make sure to post your questions on our Discord. We have a dedicated ICP zone where you will be able to post your questions, both technical and anything related to grants. Make sure to explain your cases, and we'll make sure to then forward them to the right people. We're quite fast, so hopefully you'll get responses as soon as you can. Although we are at ECC right now, the majority of our team is, so we might be a tiny bit slower, but we'll do our best to give you responses as soon as we can. That being said, thank you all once again for being here, both for the launch and the first workshop. See you again tomorrow afternoon. Afternoon in Europe where we are based, but whatever the time is going to be at your end, it's going to be 5 p.m. Central European time. Invites will be in your calendars for the second workshop of the series. Thank you all for being here. Thank you, Moritz, once again for an amazing workshop. As a matter, it took a bit longer. I think it was quite exhaustive. Then it was then showcased a lot of great examples. Nice to see some engagement from the chat as well with some great questions. And hope everyone enjoyed the event. See you again tomorrow.
Bye, everyone. Thanks for joining.
Bye.
Bye-bye.
See you.